If you opened your primary school science textbook, we'd know three fundamental primary states of matter: solid, liquid, and gas. But now that changes. Microsoft has introduced Majorana 1, the world's first quantum chip powered by a new topological core architecture that it expects will realize quantum computers capable of solving meaningful industrial-scale problems in years and not decades. Microsoft says that it has created a new state of matter, one that could redefine computing as we know it.
We see the states of matter every day. Solids keep their shape, liquids vary but keep their volume, gases expand to fill the space they're in, all defined ultimately by how their atoms behave. But what if there were more? What if, under the right conditions, you could engineer more? States that have only ever been theorized, that would change how subatomic particles actually behave? Last year, we were able to observe it for the first time. And this year, we're able to control it and use its unique properties to build a topoconductor, a new type of semiconductor that operates also as a superconductor. With this material, we can build a whole new foundational architecture for our quantum computers, a topological core, allowing us to scale to not tens or hundreds of qubits on a chip, but millions, all in the palm of your hand.
Majorana's theory showed that mathematically it's possible to have a particle that is its own antiparticle. That means you can take two of these particles and you bring them together, and they could annihilate and there's nothing left. Or you could take two particles and you bring them together and you just have two particles. Sometimes it's nothing, the zero state, and sometimes it's the electron, the one state.
Traditional computers process information in binary, ones and zeros. But Microsoft's quantum computers use qubits, which can be both at the same time, making them exponentially more powerful. Companies like Google and IBM have spent years developing quantum computers using superconductors. But Microsoft is taking a different path. They have created something called topological qubits, a breakthrough that could finally make large-scale quantum computing possible. By combining semiconductors with superconductors, Microsoft has built qubits that are faster, more reliable, and significantly smaller, just 1 by 100th of a millimeter.
At the core of a quantum computer are these qubits. Qubits are like our classical bits, right? These are essentially zeros and ones in a transistor. And we need the analog of that in quantum computing. The analog is a qubit, a quantum bit, that serves as that core information unit. It's where we store the information and then we process on those qubits to create computation and ultimately get solutions back out.
This innovation could pave the way for a million-qubit processor, a chip that fits in your hand but can solve problems no supercomputer on Earth ever could. The impact? Medicine, AI, climate modeling, and even cryptography could advance at unprecedented speeds.
It really has taken quite some thinking, right? Some time to design a device, design a chip that can enable measurement of this literally elusive particle. We've designed a chip that is able to measure the presence of Majorana. Majorana allows us to create a topological qubit. A topological qubit is reliable, small, and controllable. This solves the noise problem that creates errors in qubits. Now that we have these topological qubits, we're able to build an entirely new quantum architecture, the topological core, which can scale to 1 million topological qubits on a tiny chip.
Every single atom in this chip is placed purposefully. It is constructed from ground up. It is entirely a new state of matter. Think of us as building the picture by painting it atom by atom. In a regular chip, the computation is done using electrons. We don't use electrons for compute. We use Majoranas for computing. It's an entirely new particle. It's half electron.
When we look at the design of this chip, right? First of all, you can fit so much on just a small form factor, right? This chip can store over 1 million qubits, right? Over 1 million can fit on just this small form factor. In addition, we don't want to wait centuries or millennia for a solution. And so this chip also offers the right speed to get solutions from the chip in a reasonable, efficient, amount of time. That's the beauty in this qubit design, the topological qubit. It has the right size, the right speed, and the right type of controllability. And all of that together means that it has an ability to scale like no other.
Microsoft Chairman and CEO Satya Nadella called this a fundamental leap in computing, one that could bring true quantum computing not in decades, but in years. The race for quantum supremacy is on. And with this breakthrough, Microsoft just might be leading the charge.